All right, welcome back. Now we're looking at 06D-60, a regular heptagon. Let me open my book here. So, yesterday we did 06C-60. We got our answer to be 109. Uh, so, if you were here yesterday, then you would have seen the process, but it wasn't too bad. This one's pretty straightforward as well. So, a heptagon has 7 sides. Of course, you can even see it if you didn't know that already. You can see the diagram. Uh, And honestly, this didn't necessarily have to be a geometry problem. It gives us all the information. So, but I'll still draw it just so y'all can see. So, the fastest way I'm just going to solve for it is probably just divide this area into 7 parts. We're going to divide it by 7, and that's going to give us the area of any one of these triangular areas. Let me try drawing it a little bit better. So if you want to draw it like this, you can see that there's 7 parts. There's 7 different triangle sections, right? Imagining I drew them all straight and that they were all that was the center right there. Again, it's a little bit wobbly. You'll have to bear with me. So uh, if we divide it by 7, we'll get the area of just one of these, right? And then we could solve for it because you could just make a right triangle. So if we divide it by 7, we get 477 divided by 7, we get 68. So this area of this triangle is 68.143, roughly. Now, I'm going to try to find what that angle is right there, because we don't know it initially. But since, sorry, um, so since we know this entire, oh, this entire inner angle must be 360, right, because it's a circle, this angle right here must be 360 divided by 7. So that angle right there is 51.4289 or whatever. 51.429. Now, I'm going to cut it in half. Okay. Again, sorry for the poor penmanship, but I'm going to cut it in half, and which bisects the angle. So we are now looking at a right triangle. I'm going to draw it a little bit bigger and to the side, not at the top. Something like that. Okay. So that angle right there, as we already said, is half of this now. Let's divide it by 2. So since 51 degrees was the entire angle for that triangle, dividing it by 2 would get us the angle for just half of it, right? So that is 25.714. Now, the usefulness of that angle now is we can put a ratio between the two sides, the two legs, okay? We're solving for what that opposite side is. So I'm just going to leave it alone, right? I'm going to try to put the height in terms of half the base. So if this is base divided by 2, all right, we know with our law of tangent, so tangent of theta is equal to the opposite side over the adjacent side, right? The opposite side is b halves. The adjacent side is unknown. All you have to do is just flip the 2, right? That's how you can isolate. So the adjacent side is equal to the opposite side divided by tan of theta, okay? And following that logic, the adjacent side would then be equal to opposite, so b halves, and then tan. I'm just going to write the half alongside the tangent. It's one and the same. I just wanted to simplify. Tan of like 25.7. I'm not going to write the entire thing, but we will store that value on our calculator. So that's now that's how we can solve for it. And if we do the height, which is all this, right, the adjacent side, multiplied by b halves, that would get us the area of this entire shape, right? Hypothetically. Because normally with the triangle, especially right triangles, the two legs multiplied together divided by 2. But there's already 2 of these triangles, right? So we don't have to divide by 2. Then once we do that, once we do b halves multiplied by the height, we can multiply that by 7, or just set it equal to the 477 divided by 7. So that's the area, okay, 68.143. We just have to set that equal to, I'm just going to do 68. 68, roughly, is equal to the height, so b halves, then I forgot to write it. I might as well also multiply by b halves again. So it's b halves times b halves divided by the tan of 25.7143. So it's b times b, so that's going to be b squared over 4. But then we also need to add the tan of 25.7. Alrighty, there we go. And if we multiply by 4, so 68 roughly, 68 multiply by 4 tan of the angle, so that right there, and we're in degrees. We get what that we get the square of b, right? Which again is the base. We take the square root of it, and we get our answer to be 11.5. We round up. 11.5. That might not have been the most optimal way to solve for it. So if you had a better way, please let me know. But that's just the way I tackled it. Obviously, I could have solved a lot faster, probably within like a minute, if I wasn't showing all my steps. But that's how you would tackle it. I like to be thorough with my answer. But thank you for watching. Y'all have a blessed rest of your day, and I'll see y'all tomorrow where we go over 06E-60. All right, y'all take care.